Here you go. Good morning, good evening, good afternoon, wherever you are. We are in our second session of OSPF, BGP, and MPLS from scratch to design. And yesterday we talked about breaking the routing problem, the expectations of this course, and I think we all are on the same page. But we should continue our discussion of breaking of that routing problem, right? And when we broke the routing problem, we got a few things. And what we are doing right now is we are going into them one by one, and we are learning them, right? So again, I would like to tell you that maybe in the upcoming 3 or 4 more session, we are not going to talk about OSPF, BGP, MPLS, because there are few things, and I would say so many things, which should be under your belt or inside your pocket when we start OSPF, BGP, and MPLS. And believe me, once we have these small pieces, right, when we understand them well, uh, learning OSPF or basically any routing protocol is going to be very easy for you, right? So yesterday we talked about subnetting, but I was giving it a thought that let's make a complete course on routing. So I will let you know how to divide a particular subnetwork or network into different subnetwork, right? And as I mentioned, that we are going to do in our way. Basically, we are not going to do we are not going to learn binary arithmetic, because we are programmed to do calculations in decimal number. That is why we will be learning subnetting using the decimal number. Although the video is available, but I would really like to make this complete series so that anyone doesn't need to go here and there. So subnetting is important. I would be talking about TCP/IP layering, but yes, the level of depth which we are going into, right? It shouldn't be. For example, I'm not going to tell you TCP/IP layering in 1.5 hours, but at least we should spend 20 minutes in that. Similarly, in subnetting also. We will talk about address resolution protocol. We will talk about next hop routing table. And then yesterday, I think from this class, somebody told us that multicast should be included here. And we have included multicast, specifically layer 2, because understanding of layer 2 multicast is quite important. If I say that if you are learning OSPF, IPv6, if you understand at least a layer 2 multicast, most of the concepts are going to be clear. So again, yes, it is a overhead, but it's a good overhead, because uh, routing, basically, as I mentioned, that we can straight away start from OSPF neighbors. But believe me, if you have all these concepts under your belt, learning is going to be fun and easy. Having said that, I am again moving to a board which we discussed yesterday. Let's break the routing problem. But as you can see, there is a change. There is a change here. We have included multicast, and other things are same. For example, if you break the routing, if you want to understand the routing, basically we need to understand some pieces, and then if we combine them all together, we are going to learn routing basically in a more effective manner. So next hop, IP subnetting, routing table, address resolution protocol, TCP/IP layering. We all discussed that we are going to learn them one by one. But what I am doing here in today's board is we are including multicast, specifically from the viewpoint of layer 2. So having said that, what we are going to do is we are going to learn subnetting in somewhat more detail. I would like to spend at least 20 to 30 more minutes here in subnetting. We are going to learn some part of TCP/IP layering and address resolution protocol today. I'm not sure till how much I am going to cover, but let's see. So having said that, let's talk about subnetting. This diagram we have discussed yesterday, and I don't think that we have any problem in this diagram. What we discussed yesterday, that we have different network number 1, network number 2, network number 3, and network number 4. And basically in the era of 1980s, everybody was creating their own network, right? If we talk about a particular university, and in that university we have 4 buildings, all buildings were having their own separate network. There were nothing to connect them, and that is why there was invention of this router, which was connecting different networks. And we were talking about a specific network. If we talk about this network here, then basically we have different hosts in this network. What are the IP addresses we are going to assign them? What is the network address? What is the broadcast address? We talked about it, right? But let's talk now that if you have a particular network, for example, if we have this network 192.168.1.0, right? You have this network with /24 mask or subnet mask. And as I mentioned, that there is no meaning of this IP address unless I write a subnet mask. Subnet mask is actually adding some logic to it. So what is the meaning of a logic in an address? So this is the address. And as I mentioned that if I add /24, it is adding some logic to it. What is that logic? If I consider myself, right? If I consider myself, I live in a society whose name is Heritage County, right? Which is under a little town here in Bangalore, and the name of the town is Sarjapur, right? Which is inside Bangalore, which is inside India, and you can always go ahead that basically I live in Earth, which is a part of Milky Way galaxy, right? Inside Milky Way galaxy, we have a solar system. Inside the solar system, we have Earth, and you can say that this is the address that belongs to Vishnu, and this is basically pretty logical, right? Because we are going from less specific to more specific here. I am in India. Inside India, basically, I forget one thing. I should write the state also, which is Karnataka. Inside India, there is a state called Karnataka. Inside Karnataka, there is a city called Bangalore, and then basically town. And you can say we have a building name here. Okay. So basically, address have a specific structure, a specific logic, and believe me, guys, this IP address is also having a specific logic. So if I say that this guy is having the IP address which is 192.168.1.100, of course, I know that if I write /24, it means that 8 bits are for host and 24 bits are for the network portion. So after slash, I always write a number which represent network bits. And if I talk about a complete IP address is of 32 bits, then 8 bits are remaining, and these 8 bits are for my host. And if I do the calculation to the how many combinations I can make from 8 bits, it is going to be 2 to the power 8, which is 256. And that is what I was mentioning yesterday, that we can have inside this green network maximum 256 hosts. Out of them, one IP address is reserved for the network number, and the last IP address is reserved for the broadcast address. We discussed about that too, right? But now, what is the logic behind it? The logic behind this IP address is that starting 3 bits, or I would say not bits, the starting 3 octets, this octet, this octet, and this octet represent the network, and the last 8 bits represent the host portion. So now the question arises that right now in this network, the number of hosts could be 256, as you know. If I say number of hosts is 256, did not confused with something else. For example, people say the number of hosts can be 254. That is true. And the reason is the first address is already reserved. The last address is already reserved. So that is why we have 254 addresses from 1 to 254. The dot 0 and dot 255 is reserved. It is as simple as that, right? But and I am saying in the general TCP/IP, but nowadays even you can use this subnet and you can use this network number and the subnet number also as a IP, as an IP address, right? So there is a one specific command. If you run that command, then basically TCP/IP system thinks that you want to use the network number as well as broadcast as an address as a particular address. We will be letting you know but for now let's talk about general TCP/IP in which the first number is the network number and the last IP address number is your broadcast address, right? So we all know about it, and now the question comes: your boss came to you, right? Here is the boss, and he's saying that I do not want a network, this green network, in which I have 256 hosts, right? He wants that I have only 200 employees in my organization. And basically, these 200 employees are part of 100 employees are part of marketing group, and last 100 are part of maybe the engineering, right? I do not want more than that, but I do not want a single network. I do not want that engineering and management are part of same network. So he would like to divide this network. Which network? He would like to divide this network into two parts, right? One on the left hand side, basically what we are doing, we are dividing network one into two parts. Maybe this is the first network, this is the second network, and inside first network he is asking that he should have 100, at minimum 100, right? And the right hand side also he can have minimum 100. So this is the requirement which he is giving you. Now we are talking about subnetting because we have the network. We had the network. This is the network one. This is the network where we started. And now your boss is saying, I do not want to have 256 hosts. I want to divide this network into two parts. Can you do that for me? And here is the thing. Now you want to divide this network or subnet on this network. And on what basis we are going to do it? It is again very simple mathematics. Let's see that what we are doing here, right? So if I talk about, let's before coming to this board, right? Simply, we were talking about a network and the network number was 192.168.1.0/24, and we all know that this network is because we are having /24. It means that we are saying 8 bits are reserved for the host. 2 to the power 8 is equal to 256, and that is why in this network we have 256 hosts. Now your boss is saying, can you divide it? Absolutely, you can divide it. You can divide this 256 into two parts, right? And you can easily calculate the number that if you divide this number 256 into two parts, the left hand side of the network is going to have 128 hosts, because if you divide 256 with 2, you are going to get this number 128. It is as simple as that. The right side of the network is also going to have 128. 128 what? 128 hosts. It is as simple as that. Because in this network, we had 256 hosts because 8 bits are reserved for host. And now what we are doing here, we are dividing this network, right? Suppose if somebody come to you, he is saying, now I do not want to divide my network into two parts. I want to divide my network into four parts. You can easily calculate that there is a task. The task is to divide this 256 hosts into two parts so that we can create four networks. So network number one is going to have 64 hosts. Similarly here 64, because you are dividing 256 into four parts, and if you do that, The number which is going to come is 60 and 64, right? It is as simple as that. Somebody can tell you, can you divide this 256 into 8? Absolutely, you can do that. Then basically this 256 divided by 8, you are going to get 32. It means that you are going to get 8 networks of 32 hosts. And by the way, guys, we are calculating everything in decimal, right? It is as simple as that. But now, are we done with the subnetting? Actually, if you believe me, means if you know this, then basically other mathematics or other maths you can do, right? If you don't believe, let's see. Let's talk about the subnetting on this board now, right? What exactly this board is? I have written a particular IP address here, 192.168.1.50 and /24. You know the logic now. Then after this slash, whatever the number you are having here, it is going to be your network mask, which is here 24. The total IP address is 32, and the logic says if you subtract 24 from 32, you are getting 8, and you are using these 8 bits at the host bits. As simple as that, right? So it means that this network 192.168.1.50 contains 256 hosts, right? Because 2 to the power 8 is equal to 256. This calculation is very, very important, guys, right? Now, and what is this host? This host is the 50th host. For example, if we are having 256 hosts in this network, right? There are many hosts. So I am talking about the 50th host inside this 256 hosts, because you can assign IP address from .1, .2, .3. Starting 3 octets are 192.168.1. This is 1.1, this is 1.2, this is 1.3, and maybe this is 1.50. So you can straight away see this IP address, and you can straight away say that this IP address is the 50th IP address of a network, and that network is 192.168.1.0, because this network contains 256 hosts. This is the address of first, and the last address is 255. And we know that this number is actually the first number, which is going to be your network number, right? So if I ask, what is the network number of this host? You can say this host belongs to the network number, which is 192.168.1.0/24. It is as simple as that. Now I can ask, what is the broadcast address of this host? You can say, because this host is a part of this network, the last address of this network is going to be the broadcast. So you can say this IP address, broadcast address, is going to be 192.168.1.0, sorry, 1.255/24. This is very, very important to understand that I have written the IP address of a host now, 192.168.1.50. This is identifying a single host, right? Single host of which network? Now you can easily calculate, because if this is /24, it means 256 are going to be the host. First IP address is going to be the .0, which is reserved, and that is why that is the network number. And you all see all of these questions in your CCNA or CCNP level exam, where they give you a particular IP address, and with that IP address you need to calculate which is the subnet number for this host, or what is the broadcast address for this host. It is as simple as that, right? I would request Kanhaiya ji to be on mute, please, if you can hear me. Now, if I talk
Sorry,
about,
sir.
we have your boss here, and he is saying, just like you have calculated the subnet number and subnet mask for this IP address, First thing first, I do not want 256 hosts. I want 100 hosts in a network, at least minimum 100, right? Or he can say that it won't be more than 100 in the engineering department and the marketing department. Then you came across that it is advisable to divide this network into two parts. And here you go. You have divided this network into two parts. It means that 128 hosts should be here and 128 hosts should be here. Previously, there were 256. Why? Because we have 8 bits. I'm repeating this again and again because I want this thing to be, all of these things should go in your mind, right? So now 128 hosts in one network because you are dividing this network into two parts. This is going to be my network number 1. This is going to be my network number 2. But let's write down what are the hosts are going to be in these networks, right? So if I talk about what is going to be the first host of this network, you are going to say this is 192.168.1.0, right? What is going to be the second host? The second host is going to be 192.168.1.1. What is going to be the last host? 192.168.1.127. Why 127? You can argue with me. This contains 128 because if you count from here to here, from 0 to 127, if you count the numbers, those are going to be 128 because you are starting from 0. It is as simple as that, right? What is the IP address just before this? The IP address just before this is going to be 126. Now, you have divided the network and you know that if you divide this network, which network? 192.168.1.0, it is going to give you two networks. And these are here exactly, these are the IP address for them, right? Similarly, on the right hand side of the network, you can calculate easily that first number is going to be 192.168.1. What? You need to start from wherever you stopped in the left side of the network. See, out of 128, you have given 0 to 127 in the left side of the network. So the remaining numbers, what are the remaining numbers? It should start from 128, right? What is going to be the second IP address of the host inside this network, which is going to be 192.168.1.129, right? Similarly, what is going to be the last IP address? 192.168.1.255. What is the second last IP address? 254, right? Now, the important part is we have divided one network into two parts. But now, if you talk about this network, right? How many hosts are there? Now there are 128 hosts. Previously, how many hosts were there? 256. If you want to have 256, how many bits you need? You need only 8 bits. Why? Because 2 to the power 8 is equal to 256. You know that, right? If you want to have 128 hosts, how many host bits you need? You need only 7 bits now, right? What is the reason? The reason is because 2 to the power 7 is equal to 128. You know that. It means that now you are talking about a network in which only 128 hosts are there. And if you want to have 128 hosts, your network bit or your network bits should reduce from 8 to 7, right? It means that out of 32 bits of the IP address, you are giving 7 bits to host. And what are the remaining bits? The remaining bits are going to be 25, because if you add 25 plus 7, it is going to be 32. And you know the IP address is going to be 32-bit long. And out of that 32 bits, you have decided to give, because you are doing subnetting, and you have decided to give 7 bits to the host and 25 bits to the network. And what exactly, guys, you write after this IP address? You write number of network bits, which is now going to be 25. It is as simple as that. And similarly, you are going to write here 25, 25, 25, right? If you understand from where you get this 25 number, basically the subnetting is done. Do not worry, we will be dividing it once more time, right? But the important part here is how to calculate this number 25. Previously, this number was 24. It means that we had 256 hosts. But now this number is actually 25. It means that we are using 32 minus 25, which is equal to 7 bits for the host. We are doing reverse calculation. If you have 25, what is the meaning of this 25, right? And if there are 7 bits for the host portion, it means that you have only 2 to the power 7, which is equal to 128 hosts in this network. Similarly, we have 128 hosts in this network. And as you all know that the first IP address is going to be your network number. So what is the network number of network 1 of 128 hosts? It is going to be 192.168.1.0. What is the broadcast address of this network? The broadcast address of this network is the last IP address, which is 192.168.1.127. It is as simple as that, right? Now let's talk about network 2. What is the network number of network 2? The network number is going to be 192.168.1.128. What is the subnet mask? The last IP address. The broadcast address is going to be 192.168.1.255. Now, suppose if I write an IP address, say the IP address is any random IP 192.168.1.200/25. Can you tell me which network is this part of? Because right now this is /25. If I am saying /25, it means that 7 bits are for host, right? It means that this network is having 128 hosts. It means that this IP address belongs to this network number 2, right? Because it is lying in this range 128 to 255, right? If you calculate them, these are going to be 128 hosts. And now this IP address belongs to network number 2, whose network number is 192.168.1.128, and the broadcast address is .255. It is as simple as that, right? These are the questions generally you see in most of your preliminary exams like CCNA and CCNP. But believe me, this should be with you if you want to understand the what we can say routing, right? Because at the end of the day, in routing, these are the subnets which are going to flow, because you are going to advertise these networks in the routing protocol, so you understand them well, right? Now your boss is again now your boss again comes to you, right? And this time he is saying, I do not want 2 networks. Actually, I want 4 networks. 4 networks from what? He wants 4 network from 192.168.1.0 network from we begin, right? Why 4 network? Because he is saying this time that I don't be having more than 50 hosts in the per network. And now I have 4 division. 4 division means 4 different network. One is for sales, another is for marketing, the maybe for IT, and so many things, engineering. So now you are doing the mathematics again, but believe me, the mathematics is going to be simple, because everything whatever we are doing here is in decimal. So if I want to divide this complete network into 4 parts, you can understand. Instead of 128, now I will be having 64 in every network, right? These are going to be your four network. This is network number one. This is network number two. This is network number three. This is network number four. But the question now is, can you calculate every network number and broadcast address? Absolutely you can. If I say that this is the first network you are going to create of 64 hosts, what is the first IP address? The first IP address is going to be 192.168.1.0. It is as simple as that. What is the last IP address? The last IP address is going to be 192.168.1.64. Is it 64 or 63? It is going to be 63, right? And the reason is from 0 to 63, if you count, it is going to be 64. It is as simple as that, right? So the last number of this is going to be 63. You can write the middle number 1.1, 1.3, and maybe the second last number is going to be 62. These are the numbers which you actually provide to host inside this network. The first number is reserved for the network number. You all know that. And the last number is for the broadcast address. So you divided this network into four parts, and this is going to be your network number one. But if I want to calculate what should I write after this slash? It is going to be pretty interesting because now you are having 64 hosts. Just try to pay close attention. You begin with 256, right? You begin with 256. You divided it with 128, and now you are talking about 64. To have 256 hosts, you need 8 bits. To have 128 hosts, you need 7 bits. And to have 64 hosts, you are going to need 6 bits because 2 to the power 6 is going to be 64. It is as simple as that, right? Now, IP address is of 32 bits. Out of 32 bits, you have given 6 bits to host, and the remaining bits are going to be 26. It means that you need to write 26 here because you always write network bits after slash. So 26 are network bits, 6 are host bits. Similarly, if we talk about the second subnet, the second number, the subnet is going to be again of 64 bits. 64 host. What is going to be the first IP address? The first IP address is going to be 192.168.1. Of course, where you finished last time. It is going to be 64 here. What is going to be the last IP address? The last IP address is going to be 192.168.1.127. If you calculate 64 to 127, it is going to be 64 hosts. What should be the mask I should write? The mask is going to be 26 again because we have 26 hosts. It is as simple as that. This is going to be the network number of my second subnet, and this is going to be the network number of my third. This is going to be my broadcast address of the second network, right? Similarly, you can calculate here also. What do you want to calculate? Again, you are creating the third network. What should be the first IP address of the third network? 192.168.1.128, wherever you have finished last one, right? And the last one is going to be 191. If you calculate 128 to 191, this is one, guys, right? 192.168.1.191. These are going to be your 64 hosts. This is going to be your first address, last address, or the network number or the broadcast number, and slash 26. You know about 26. And now the last thing I give it to you to calculate. Maybe if you are working along with me on the piece of a paper, you can calculate that the last subnet is going to have the first IP net address, which is .192, and it is going to finish at .255. The mask is going to be 26 here. It is as simple as that. Really simple, right? But here is the thing. Now, I would like to give you an example, and I think it is asked in most of the interview questions, right? I am not explaining the interview questions, by the way, but it is pretty interesting to know that generally what people say. For example, most of the times I say, what do you think about this two IP address 192.168.1.100/25? This is the first IP address, and the second IP address is 192.168.1.200/25. Okay, and then I ask, can you calculate whether these two IP addresses are part of same network or different network? And believe me, 98% of the time, this is not about calculations, guys. This is about your knowledge on IP, knowledge of IP, right? 98% of the time, I get an answer that yes, these two IP addresses belong to the same network. And the logic which I got from all the candidates most of the time is that because we have subnet mask of 25, because we have same subnet mask, that is why we are having these two hosts as a part of same network, which is absolutely wrong, right? What should be your approach of doing? Now you can immediately think that here basically we have 25 bits. For what? 25 bits represent network, right? It means that I know the IP address is 32 bits long. 7 bits are representing what? Host. It means that the IP address of whatever this host, uh, whatever network this host belong, it is only going to have 128 IP addresses, right? From where to where? From dot 0 to dot 128, 127, sorry, right? Similarly, this host, if I talk about a network of this host, that which network this host belong, you can understand that this host belong to a network which start from dot 127 or 8 to dot 100 and sorry 255, right? These two are completely different networks, right? So if I draw the network of this host, this is the network, from dot 0 to dot 127 are the hosts inside this network, right? Only 120 hosts. But dot 0 and 127 is the reserved number, so you cannot assign these IP address to these hosts. It is as simple as that, right? Similarly, we have a different network here.
Sorry, Vishnu.
Yeah.
The 255 should be 256, I think, at the right side. Yes.
No. The last at basically we are talking about 0 to 255. So if you calculate, it is going to give you the 256 results.
But if you count from 128 to 255, it doesn't get 128.
Okay, let's write it on the confusion should not be there, right? Let's write it on the number line. Can you agree that from we can have 2 to the power 8 bits, we can generate only 256? You agree?
Yes.
Yeah. So the first number which I am going to start is from 0, right? And the last number, it is going to be 256. Sorry, 255. Because now I am not starting from 1. If I write 1 to 1, 2, 3 to 256, this is going to be 256. But if I start from 0, then basically the last number is going to be 255. You agree? From here to here?
Yeah.
So how many number from here to here are 256? If I divide it, where should be the division point? The division point is 0 to 127, which are going to be your 128. And from 128, if you calculate 255, it is going to give you 128. Simple?
Yeah.
Perfect.
Okay. It's my mistake.
No, no,
Okay.
no, it's
Thank
not a
you.
mistake. Basically, everybody is having this problem. So I am glad that you asked this question. Thank you so much. So,
Okay.
so,
Thank
Yeah,
you.
Vishnu, just one thing.
mhm.
Yeah, just Burak, this is not your mistake. Like I also had this in my days, initial days. Yeah, so everyone has this. It's
Mhm.
very common.
Yeah. Okay. Thank you.
Yeah. So if I talk about, so this is the most common thing which we get, right? And because people do not understand this concept, that is why they do not understand whether we are talking communication inside a same network or different network, which is the starting point of any internet protocol discussion, right? If we are talking about if we are talking about communication inside the same network, means suppose this is host A, this is host B, which is part of the same network, then I do not need routers at all. I do not need routing at all, right? So if your perception is that this IP address and this IP address belongs to the same network, you are straight away going to say that they can talk via a switch because these are part of the same network, right? Which is not the case. Now you can easily understand that this IP address and this IP address belongs to two different network, and if they belongs to two different network, you are going to need one device which can switch packets, which can take packet from this network and give packet at this network. It is as simple as that, right? I think we are having a little more discussion on that, but believe me, guys, these are the things which are really, really important when you start learning OSPF BGP. These things are really basic. So, having said that, I would like to take a pause of at least 2 minutes here. Please unmute yourself. If you have any slightest of doubt in your mind, please do ask. Otherwise, there is no question, uh, no advantage of joining the live session. You can all see in offline videos. Okay. Please do ask if you have any questions. So I think I have a hand raised from Supreet. Supreet ji, please ask your question.
Hey Vishnu, thanks. So just wanted to know that, so let's say for example, I'm specifically talking about one specific vendor, that is Cisco. So how does, when we give the longest preface match command, so how does it work exactly for this subnetting, or is it related to this thing, or it's related to the IP routing table that we are going to cover?
Yeah, we are basically jumping ahead. We will be
Okay,
covering that. Do not worry about it. Okay.
okay, thank you.
Mr. Bharat Singh ji, please do ask your question if you have any.
So I got your concept, and it was very much needed. The only question is that, like, since till now also, like, I use the subnet calculator to know it, like, in a quick way.
Mhm.
Like if I will do the my calculation, then I will come to know, I know I have some fundamentals in my initial days, but it takes time. So in order to do it fast, I just use the subnet calculator. So is there any way? Like we have since starting of the class, we are working with this 192.168 1.0/24 subnet. So now I'm used to of this, but sometimes we get some random subnet on which we have to quickly know that, okay, what is the network ID and what is the /24/16 is well, quite easy. But when you get to know /29 /28, and there is some middle IP, suppose /45, so what is the network ID? So is there any quickest way to know that?
See, the calculations, whatever the logic, whatever we are doing here is going to be same. Doesn't matter if you have /23 /29. I'll show you, right? But yes, to your second point, see, in our primary days when we were in primary schools, or basically from first to fifth, we all learn addition, right? We all learn subtraction, division, and everything we knew, right? But now we have the calculator also. Whatever the calculation we want to do, and simply we have a calculator inside our mobile phone and so many places. We do one calculation, nothing wrong in that, right? But you should understand the logic behind that, how to add, right? Then that is what my point is. It is perfectly fine to do the calculations in a particular time because we are humans, right? We are not calculators at all. So if you are going to take some time, maybe 5 minutes of time, when you see an IP address, suppose if you see an IP address which is which is 172.16.1.0 and slash maybe say 29, suppose, right? It is perfectly fine to spend 5 minutes here to know the broadcast number or the subnet number of this host, or to calculate how many networks, how many hosts we have in this network, right? And I would really advise you to use calculator or subnet mask calculator if you are doing a subnetting on a large scale. That is also perfectly fine. But my point is that if somebody asks you that whether this host and this host are part of the same network, you should easily able to recognize, doesn't matter. Generally, my way is calculate in your mind. That is perfectly fine. And if you are doing in decimal, this is going to be great. Also, I can explain this example. Right now we have 29. The calculation or the process which we have discussed is going to be same. For example, if we talk about 29, what is the meaning of this 29? This 29 is the network bits, right? Right? So as the IP address is only of 32-bit length, then what is the host numbers? The host numbers are going to be 3, right? And with these 3 numbers or 3 binary numbers, you can have 2 to the power 3 is equal to 8 hosts. It is as simple as that. It means that we are talking about here a network which is having only 8 hosts, right? Means pretty simple network in which we can have only 8 hosts. And if we talk about this, then 172.16.1.0 is going to be the first host because we are talking about this network here. Then dot 1, dot 2, dot 3, dot 4, dot 5, dot 6, dot 7, and dot 8, right? This is going to be my first number. This is going to be my last number. First number means the network number. The last number means the subnet number. Sorry, the broadcast address. Okay, and you can assign only these IP address from 1 to 7. Or I am extremely sorry, the last number is going to be 7 because 0 to 7 is going to be your 8 numbers. It is as simple as that, right? Similarly, anybody can write any number 172.16.1.100 and maybe not 100. Let's say 17, right? /29. Again, your logic is going to be same, that we are talking about a subnetwork who is having only 8 hosts. So you must be thinking from 0 to 7 was taken by first subnet. From 8 to 15 was taken by second subnet, and we are talking about the third subnet here. And third subnet, the starting number is .16, which is your network number. So the IP address, so the network number of this host is going to be .16, and you can add 7 on top of it. Like 23 is going to be your last subnet mask. So I hope you have understood this. If not, please repeat this video. The process is going to be absolutely same for any class, any IP address. Doesn't matter what is the slash, what is the network network mask you have written here. Having said that, Kamaljeet ji, I would like to take your question after some time because I need to cover, and do not worry about it because because today is Saturday, I can sit maybe half an hour long here. So no problem, I will be taking all of your questions. So, but let me go through the remaining thing. But I would say that did I able to answer the question which you have asked?
Yeah, sure.
Perfect.
Thank you.
Perfect. Perfect. So let's move to the next board, which is all about TCP/IP layering, right? We will finish this board quickly because I presume that we all know about it, right? So actually, guys, what was happening again? Let's move to 1970s era, or maybe before that, 1960s. People have built these computers, right? Now the problem was how I make sure that these computers can communicate with each other. And that was in need of an hour at that point of time, because computers were there, but nobody was able to make sure that how we can make these two computers communicate, right? Or talk. The problem was how we can make these two computers talk, and that is why there were two models which were under development at that point of time. One is OSI model, the other one is TCP/IP model. We all know that TCP/IP model won the race. What was the mindset behind creating this TCP/IP model? So there were a group of people who were doing this thing, right? The problem was again how to make sure that these two computers are talking, right? Or can talk. And believe me, this is the simple approach that these guys were also taking. These guys were saying, if you see a problem which is pretty huge, and the problem is humongous here, right? We are talking about how to make sure, or how basically this computer A can talk to computer B. The problem is big. So these guys, the developer of TCP/IP, were thinking it would be nice to divide this problem into different pieces, right? Work along on these pieces individually and then combine it so that we can get because if you work on a huge problem at once, it is really, really difficult to manage it. And that is where basically we got the birth of these layers. So these devices, these guys were saying that we should assign few people who should work at the application part. Means the responsibility should be that you are going to take the packets or the information or the data from the application and process that data. Then basically they are saying there must be something who is responsible for process to process delivery. What is the meaning of process to process delivery? If basically at the source I have an WhatsApp application, somebody need to make sure that the packet is at the destination is going to receive by the WhatsApp application only. So they assign few people here. Then basically they assign few people to talk about host to host delivery, means which should be responsible for making sure that the packet is reaching from one host to another host. Doesn't matter how many networks away these hosts are. Then basically there were some group of people who were working to make sure that the packet inside a particular network can be delivered. And then few people were working on the physical aspect, that whatever the packets are coming, at the end of the day, there is information 1010 which should go out. And believe me, guys, whatever these guys thought in terms of different problems, or basically a division of this problem, right? Every division resulted into a layer which we known as TCP/IP model. And if any computer is talking on internet today, please make sure, or please rest assured that that computer is going to have implemented all of these layers. It means that that computer is having TCP/IP. That doesn't matter that whether this computer is your mobile phone, your laptop, your personal computer, or anything which is talking on internet, it is using TCP/IP. And if it is using TCP/IP, actually we are talking about these layers. So in TCP/IP, basically we have these 5 layers. You can argue with me that whenever I go on internet and search for TCP/IP, they are giving me only 4 layers as a result. And why you are teaching us wrong information? Just wanted to tell you that TCP/IP never says that there should be 4 layers or 5 layers. It has the definition specific to all layers, but it never says. I believe I can explain you much better when I consider the 5-layer TCP/IP model. And that is why we have application transport network and data link. The most portion which we are going to devote here in this course is going to be network and data link. So these are most crucial for us. Even not the data link, but yes, some portion of data link is required to understand few of the functionalities of network routing protocols. So mostly we are going to spend time in network layer and data lake layer, but let's define actually what happens. Your computer application, suppose we are running an application here, maybe the Chrome application, right? Which wants to talk to this guy who is running a website here, right? It is as simple as that. So you have opened your browser here and you are accessing this website. What is going to happen? This application is going to create some data, maybe a GET request, right, from the website. The application layer is responsible to collect that data from the application and pass this data to the lower layer. As I mentioned, this layer is responsible for process-to-process delivery, right? When this data reaches at the destination, it is the responsibility of the transport layer to make sure that it gives the data to a correct application. For example, maybe instead of using Chrome, you are using WhatsApp here. And this data, whatever you are sending to, is for WhatsApp application. And here many applications are running. On what basis the destination is going to decide that this data is for what application? This is the responsibility of transport layer. The transport layer is also responsible that your data should not be missed during the transit. Maybe a router is busy, it can drop the packet. So this is the responsibility of transport layer to make sure to resend the packet. And by the way, guys, the TCP protocol works at this, although UDP also works, but the major protocol is TCP here in the transport layer. And we have already created 12-hour videos on that, right? So I cannot explain everything what transport layer does in few minutes because it has a proper theory. But believe me, that is really, really simple. And TCP is also asked in most of the interesting interviews, right? And I'm not sure why a network engineer has a fear of TCP because TCP is really a simple protocol. If you don't believe, just have a look at my 12 hours course. Very simple, very easy to understand. Now, what is this blue color thing which is added by transport layer? So as you know that this data, when it is going to reach to the destination should know to which process it belongs. That is what transport layer at the sender side is going to put this information, and mostly this information is put in terms of port numbers, right? If it is going to port 80, this destination comes to know, okay, I need to send it to the application which is listening on this port 80 here on this computer, right, or the server. So basically, after this data, transport layer adds some amount of information. I'm not saying only port numbers. It has some more things also. But actually it is adding something, and that is what we known as TCP header. If we are talking about TCP, if you're talking about UDP, UDP is going to have its own header, right? Now the transport layer responsibility is done. It doesn't care what is below it, but it is saying whatever I have created, it is the responsibility of the lower layer protocol to send it from source to destination. And what is the lower level protocol in TCP IP model? That lower level protocol is IP, Internet Protocol, right? For network layer, whatever is coming from top, actually a data for it, right? Or the payload for it. It doesn't care that what it has, right? Although it is having data plus TCP header, but to IP layer, it is going to be always data from here to here. And now network layer is responsible for sending this packet, whatever, sending the information, whatever it is receiving from the transport layer end to end, means from source to destination. And that is why it is going to write the IP address. And now you understand the IP address, the significance of the IP address, that IP address is going to identify a particular host on the network, right? So it is going to put the destination IP address, also the source IP address, and it is going to send it, right? It doesn't care what is below it, right? But the below is there's another layer which we call data link layer, which actually puts the layer 2 header. At IP, it is going to be IP address. At layer 2, it is going to be generally, most of the time, because we are so used to see this Ethernet everywhere, because Ethernet has won the race. Whenever we used to connect to different computers, we use Ethernet cables, we use Ethernet network. And on Ethernet network, basically, we have a different scheme of addresses, which is MAC addresses, right? You can argue with me why in the same protocol stack, why we are using two different addressing schemes. So there is a complete and logical answer for that, which I don't think is necessary here to explain. But if you are curious like me, that why we are having two addresses, because when I give you an example of myself, that I live in Bangalore, which is a part of Karnataka, which is in India, I have only one IP address. I do not have two addresses, right? And through this address, anybody can reach my home. It's as simple as that, right? Then why in TCP/IP model we have two addressing scheme? One is MAC and the other is IP. Why can't I have only IP and can then call it a day? Right? It is an interesting discussion. So the broader answer is, or basically if I do not go into details, that Ethernet and IP were developing at the same time. People have created the Ethernet protocol already, which was working on the MAC address. So believe me, if we are talking inside a same network only with the help of these switches, we do not need IP address at all, right? Because switch works on the Ethernet layer. Switch sees the MAC addresses and forward it. But developer of TCP/IP know that somebody has created the Ethernet, so they involve this Ethernet, and that is why we see the data link layer, in which IP, irrespective of whatever we are using here, right? This is my IP packet. I can call the data link layer. At the data link layer, maybe the frame relay could run, maybe Ethernet can run, or maybe any other technology can run, right? But if we are calling Ethernet, then it is going to put its MAC addresses, because Ethernet is built on the MAC addresses. As I mentioned, I would not be able to explain the full story behind it. Why do we need MAC address if we already have IP address? There is a video on my channel. Just go and watch it. But I don't think it is pretty much important, or if it is, then we are going to discuss it during this course itself, right? The last layer is the physical layer, where actually whatever you are getting it from here, it is actually flowing over the wire. So if you connect these two computers using a wire, these bits are flowing over this wire, and it is interesting to visualize them, right? How? Because on this wire only electric current can pass, right? So you can vary this electric current. So if it is 1, you can say it is maybe the voltage of the current. You can say 5 volt. If it is 0, it is 0 volt. So you can vary this value along with the 1 and 0, and basically it is going to signal at the destination that, okay, if it is plus 5 volt, then basically it's a bit 1. If it's 0 volt, it is 0. And then basically you can interpret that how data is actually flowing. If it is a light, or if this cable is not the copper cable, if this cable is the optical cable, then instead of current, actually light is flowing over it, right? And we can again encode these values there so that the destination can understand. So basically this is the whole sole idea of having the layering approach. But this is very, very important to understand, that at layer 3, we talk about IP addresses, right? Whatever we are getting from the transport layer, we encapsulate and put a header at the network layer, which is the IP, right? Which is the IP header. Although IP header contains a lot of things, but we are most concerned about the source IP and destination IP, and maybe the TTL, which we are going to discuss with you, right? Having said that, I would like to take 2-minute pause here if you have any question on this board. And I don't think that you should be having anything because we have been reading this all from our college days. But if it is completing your picture, this is perfect. And why I am going fast here, because I would really want your 15 more minutes to complete one another topic, which is address resolution protocol. So if you can please spend 15 to 20 more minutes today, we can complete that. Do you agree with me? Can you give me your 15 minutes now?
Yeah, sure, Vishnu. Yeah.
Perfect. So if that is the case, let's move to the next board where we are going to talk about address resolution protocol, right? First thing first, let's leave about address resolution protocol, the name and everything. Let's try to understand why do we need this, right? What is the problem? So first thing first, we are talking about communication inside a same network. This is my network. In this network, there are maybe 2 or 3 hosts, right? The network number is 192.168.10.0/24. It means that there could be 256 hosts in this, right? To be precise, 254. This is host A, this is host B, but the important thing is they all are part of same network. We are not talking about communication between network. We are talking about communication inside a particular network, inside a particular network hosts. Maybe you can have switch here. You can all connect these things to switch and all of these hosts will start communicating with each other. But do you see a problem here, right? How these things are going to start. So that is why I have taken example that we have 2 hosts, host A, host B. The IP address of host A is 192.168.10.100 and the MAC address is A:(A:)A. The IP address of host B is 192.168.10.200 and the MAC address is B:(B:)B. It is as simple as that, right? These 2 hosts wants to communicate. So what host A is doing? It is pinging host B. It is writing in its command line ping 192.168.10.200. Why do we ping, guys? We ping to check the liveliness of other host, whether the other host is alive or not. And the second thing is how much far away it is from us in terms of time, right? So the network is pretty simple. These 2 hosts are connected with a switch, and this switch is totally or purely layer 2. It means that it doesn't understand IP address, because if I talk about layering approach, right? IP at the layer 3 and switch is at layer 2, right? Sorry, this was my network layer, this was my data link layer, and if I talk about switch then, or a specific layer 2 switch, this layer 2 switch works at the data link layer, right? And data link layer only understand if we talk about Ethernet, the MAC addresses. So this switch is purely L2. It means that it can understand anything which is at L2 or below L2. Means it can understand layer 1, which is the physical layer, or layer 2. If I talk about router, and if I say router is a layer 3 device, it means that it can understand network layer, it can understand data link layer, and it can understand the L1 or the physical layer. We talk about the highest layer understand by this device. So try to make sure that you understand this well. If I'm saying that firewall is a layer 7 device, right? and I'm referencing OSI model, it means that it understands layer 7 and all the layers below it. It is as simple as that, right? So this switch, if I'm talking about this switch 1, this is basically the layer 2 device. It means that it can understand the data link layer as well as the physical layer. And basically, we are talking about Ethernet technology here. So these are my Ethernet cable. This is the Ethernet switch. And I'm issuing a ping command here. So no problem. Whenever I issue a ping command, basically my ICMP message is created, ICMP echo message, whose source IP address is going to be 192.168.10.100, right? The destination is going to be 10.200. It is as simple as that. This is going to be my IP packet at layer 3, which was created by this host. Why? Because this host is also implemented TCP/IP model, right? Because it wants to talk over internet or basically inside a same network. So if this host is having TCP/IP at layer 3, it has generated the ICMP message with source IP address of this one, the destination IP address of this one. So this is the IP message generated by this host. Now, to send this message out of this interface right here, which is the Ethernet interface, I need to put source MAC address as well as destination MAC address. We need to find out what is the destination MAC address, right? So to make this diagram a little bit uncluttery, what I am writing here is that I am showcasing you IP packet in orange color, and now this is the IP packet, right? What is this IP packet actually? This IP packet is having source address 10.100 and the destination address 10.200, which is generated as a result of ping, right? Now I'm showcasing here you the L2 part or the layer 2 part where I'm going to write source MAC address and destination MAC address. What is the source MAC address? Of course, the source MAC address is going to be the MAC address of this host, this one right here, which is going to be A:, although the MAC address is of 48 bits. But I do not want to clutter this board, and that is why I'm writing A:, A:. You can understand that. And here is the problem. The problem is I do not know where is my destination MAC or what is the destination MAC, right? Even if I tell you and try to understand this thing, the routing, which is the whole sole purpose of this course, actually starts from host itself. What is the meaning of the last statement? I'm saying that actually this host is capable of doing routing. Why? Because whenever I write 192.168.10.200, the host calculates whether I am talking inside my own network or I am going to talk to totally different network. And believe me, it can calculate. Now you can calculate after learning subnetting, right? What is the network number of this IP address? The network number is 192.168.1.0. What is the mask? Mask is /24, and that is why you assign this number with mask in your computers, right? If you are assigning statically, you have to provide the IP address as well as the mask, right? Why you are doing that? Because if you do that, host can calculate the network number and how many hosts are there in this network number. It is as simple as that. The hosts are 256. This host can easily calculate on the basis of this IP address which you have configured, on the basis of this network number you have configured, that this host is going to talk about 10.200, which is part of its own network, right? It means that we are talking here a communication inside a particular network. This host understand that. This host understand the networking. This host understand whether it is doing the routing or whether it needs to do the routing, means it needs to send the packet to another network, or it is sending packet its own in its own network. Why it is important? It is important because if it sees that the destination address is in its own network, it can ARP to it, or it can try to find out what is the destination MAC address. But if this destination is not in its own network, then basically the things are totally different, right? We are talking about communication inside the same network. This host know that I have initiated a ping to a host whose destination address is part of my own network, so I can safely assume it is nearby to me, and I can easily find out the destination MAC address. And what is the destination MAC address? The destination MAC address is discovered by a protocol which is named as address resolution protocol. Now, the important thing is this packet is not created, this packet is not complete because we do not have destination MAC address. And if the packet is not complete, by the way, guys, at the layer 2, the unit of the packet is fragment. Sorry, the unit of the packet is frame. And if this frame is not complete, it cannot go into this wire. That is why this host is going to store this frame into its memory and start doing address resolution protocol. What is the meaning of it? It wants to find what is the MAC address associated with this IP address. Which IP address? 10.200. It straight away asks in this network what is the MAC address associated with this IP 192.168.10.200, and actually this is your ARP message, right? This host is asking everybody in this network that please tell me what is the MAC address associated with 10.200. Who is going to tell you? This host itself. But at the first place, this message should reach here, and that is how we need to talk about this address resolution protocol message here, right? Now, this packet which was not complete was stored in the host memory, and this host is generating an ARP message, specifically ARP request message, in which it write the sender MAC, sender IP, target MAC, and target IP. What is the meaning of it? The sender MAC is going to be simple, right? A colon, A colon, A. The sender IP is going to be simple 10.100. The target IP is going to be simple 10.200. But what is the target MAC? We do not know. And that is why we write 0 colon 0 colon 0 here, right? This is basically your ARP message which you are going to put on this wire. But this is ARP protocol message, right? You cannot put it on this wire unless you have the source MAC and destination MAC, because this switch is going to understand only source MAC and destination MAC. That is it, right? So I am denoting this ARP message with this yellow color here, and again I am going to write source MAC and destination MAC here. What is going to be the source MAC? The source MAC is going to be A colon A colon A. What is going to be the destination MAC? Again the same problem. And you can argue with me that Mr. Vishnu, we are in the same loop, right? How we are going to send this message if we do not have the destination MAC? And that is why there is a concept of broadcast address. So if you write here all numbers as F, so basically in Ethernet we have programmed this switch that if you get an frame with its destination MAC of F colon F colon F, it is your duty to send it on all the ports except the one on which it was received. So as you know that this network contains 256 hosts, there might be some more hosts connected to this switch, right? So what this switch is going to do, this switch is going to send this message to every port which is connected to it, which is in upstate, right? Except the port on which this packet was or the frame was received. It is as simple as that. Suppose this frame reached to this host number C. It is every host, because it is running TCP/IP once again, right? Every host is programmed to check the content of a frame which is having F:(F) as a destination MAC address. Every host is programmed to do that. So try to understand, if there are 256 hosts attached or 250 hosts attached to this switch, every host is going to open this packet because switch is going to send this on everywhere, and that is why we known as this message which is having F:(F) as a destination MAC address as the broadcast frame, and switch is broadcasting it. The frame reaches F here, C host. C host is running TCP/IP. It is programmed to open this, and once it is open this frame, what it is going to see? It is going to see this ARP message. In this ARP message, the important part is what is the target IP address. The target IP address is 10.200, and of course we haven't assigned 10.200 to C because we have assigned 10.200 to B in this network. So it means that C is not going to reply. C is going to say this ARP broadcast message is not for me. It is going to silently discard this message. But as you know, this message is going to be on this link also, the ARP message, right? And again, host B is also programmed to open any message which is having destination address of F:(F). It is going to open that message. And interestingly, it is going to find that 10.200, which is the target IP address of this MAC, of this ARP message or ARP request message. It is for it, right? Because 10.200 is the IP address assigned for this host B. Now this is the responsibility of host B to generate a reply message so that host A can complete this packet. How it is going to generate? Just try to think, right? This ARP message or ARP reply message is going to be generated by this host here. Again, the values are going to be same: sender MAC, sender IP, target MAC, target IP. Sender MAC is going to be now B:(B:B) because host B is the sender now. 10.200 is going to be what? The sender IP. The target MAC is going to be A:(A:(A). And the target IP is going to be what? It is 10.100, right? Switch is intelligent enough. If you know how switch works, basically it is creating an entries here, right? Whenever it received this frame, it came to know that A:(A:(A) is connected. Suppose it is 0/1 or 0/1 here. It is connected to 0/1. And what is this? This is the CAM table of the switch, which is built on the basis of source MAC addresses, right? So whenever this host is sending the broadcast message, switch is intelligently developing its CAM table, right? Now this is the ARP message. You cannot send ARP message unless you have the source MAC and destination MAC. So source MAC is this one, destination MAC is this one, and this message is ARP message. Source MAC is going to be B:(B:(B), and destination MAC is going to be A:(A:(A). This message is going to be received by the switch here. Switch is going to check what is the destination MAC. Destination MAC is going to be A:(A:(A), and now it knows that A:(A:(A) is attached to 0/1. It doesn't need to broadcast it. It is going to send it on the single port. This host is going to receive this message. What message? Complete ARP message, and it is going to see it is the ARP reply message, right? It is going to open this ARP, whatever its content, and it is going to find that the MAC address associated with 10.200 is B:(B:(B), and that is what it is going to write here. It is going to complete the message. Now the packet is complete. Now they both can talk. Similarly, when this message was received, this switch was building its CAM table that B:(B:(B) maybe attached to 0/2 port, and maybe this port is 0/2. It is as simple as that, right? But why we are reading this ARP? Because ARP is very, very important in understanding routing. You all have heard about it, that when we have a particular network, right, it generates ARP whenever two hosts inside that network wants to communicate, they are going to generate ARP. And routers are there basically to make sure that whatever ARP you are generating in a particular network, it should not be forwarded to another one. But it doesn't mean that routers cannot generate. Why I am saying this, all these things? Just try to understand now a scenario, right, where we have a big network. This is my big network here. And in this network, I can have 1024 hosts. It's a huge network, right? Now we are not talking about 8 hosts, 10 hosts. We are talking about 10 and 24 hosts. If we want to have 10 and 24, or maybe 1020 hosts, what should be the mask of such network? The mask of such network is going to be 22. Why? Because we are using 10 bits, because 2 to the power 10 is equal to 1024, right? And now we are talking about so many hosts here, 120, which is connected to these switches, right? And why I have taken an example of a bigger network? Because I want to showcase you that we need subnetting. Otherwise, there is going to be problem. Why? Consider now we have 100 and maybe say 900 hosts are up and running at a particular time in this network, which can have 1024 hosts. If that is the case, if this host generates an ARP when it wants to talk to this guy, try to think all other hosts which are alive on this network, maybe 900 hosts at that point of time which are alive, had to process this ARP frame. And just try to understand, there are so many hosts here. If there are so many hosts, Bharatji, could you be please on mute? Yeah, thank you so much. So if there are so many, if there are many hosts in this network who are basically doing ARP, try to understand every host unnecessary need to process that ARP broadcast, because we want this system to be work. Then TCP/IP is implemented in a way that if you are receiving a ARP broadcast, you have to process it to check basically this message is for you or not. And that is why basically the large network doesn't scale, and that is why you have tasked to subnet this network, right? Maybe in two or three, or three or four parts, and that is why subnetting comes into picture, right? Interestingly, basically, if you are aware of the concept, what we are doing here, we are just limiting the scope of ARP, right? Or we are limiting the scope of ARP domain, that if somebody in this network is generating this ARP message, it should reside into this network. It should not go into this network, right? You must have heard about the concept of broadcast domain, right? Which is your VLANs. If you're creating a VLAN, what you are creating a broadcast domain. It means that a particular ARP message should reside into that domain only, or into that network only, right? It is as simple as that. So it is not advisable to have a huge networks. And that is why you need subnetting. And that is why we understood subnetting. Now try to understand, we had a routing puzzle, right? We want to learn routing. We have divided this into 6 pieces, right? We understood first subnetting, we understood second TCP/IP layering, we understood third ARP, although We have completed our till 90% only, because we have discussed about what is going to happen when we talk about communication of two hosts inside a particular network. There is more to it which we are going to cover in Tuesday 7 a.m. in the morning. Having said that, I would like to take your questions now. This is what I would like to cover.
This is Burak Vishnu.
Yeah.
Will we talk about proxy ARP in this lesson?
Not in this lesson, but without proxy ARP, you cannot understand static routing, right? We are going to cover it, but not today. Whenever we are going to study static routing, we are going to do that. But yes, your question is makes sense, because we are going to cover along, because OSPF, BGP are the dynamic routing protocols, right? But if you do not understand the static portion, that how you can create the static routing, it is difficult to understand few of the things. So we will be covering static routing, and to understand static routing in a specific environment, in a specific scenario, we need to understand proxy ARP. We are going to cover it.
Okay, thank you.
Anybody else? Please do ask your questions. Yeah, Supreet I see your, sorry, Kamalji, if you can please ask, because you have been waiting for long. I'm sorry. Please do ask your question.
Yeah, no issues. Actually, I have just one question that I have seen /31 subnet configured on routers in the ISP network. So how does it work? Because it does not have any network ID or any broadcast IP.
Yeah, so that is what I mentioned, that I am talking about general routing, right? In general routing, basically the first network is your first IP address is your network number, and the last IP address is your basically broadcast address. But try to consider that at the end of the day, we can plan, right? When we were developing TCP/IP, it would be great if you can be on mute, Kamaljeet ji, because there is a disturbance. When we were developing TCP/IP, we thought that 32 bits for IP address is enough, right? But now you can see that those are not enough. We are developing a new protocol. Mainly one of the reason of developing a IPv6 is because we might be having shortage of IP address, although NAT is doing a pretty fantastic job. But still, we are going to need the new protocol maybe sometime sooner, right? So at that point of time, we were thinking 32 bits for IP addresses were okay. It is not going to be a problem. But now we want to effectively utilize, right, this IP address range. So suppose I'm again going to take this example, right? Suppose I have a network of where I am writing /30. Doesn't matter what this network is. I am writing /30. If I write /30, then 30 bits are for network, and I have only 2 bits for what? For my host. If that is the case, then if I have, let's take an example, 192.168.1.0/30, suppose. If I have only 2 bits for the network, then basically I can have 2 to the power 2 is equal to 4, which are my network, which are my number of hosts in this network. What are these going to be? These are going to be 192.168.1.0, 1.1, 1.2, and 1.3. And the subnet is 30. You all know that, right? Till here, no problems, right? 192.168.1.0 is my network number. This is my broadcast address, and these two IP addresses I can configure, right? So if I take an example of 2 hosts or routers, R1 and R2, and I can see that only one link is there, I can put .1.1 address here, 1.2 address here. But don't you think that this is a wastage of 2 IP addresses at least? This IP address and this IP address. And if I have so many links like this, which I am having in service provider network, then for every network, I am just wasting these two numbers, right? So that is why basically we have programmed these devices that if you are configuring on this point-to-point link, right, these IP addresses, then basically you can use /31 also. What is the meaning of /31? /31 meaning is that 31 bits are for network, and I have only one bit for what? For host. And for from 1 bit to the power 1, you are going to get only 2 addresses, right? Let's talk about it now. Now we are talking about 192.168.1.0/31. And if we talk about it, what is the first IP address going to be in this network? We know only 2 addresses are going to be there. The first one is 192.168.1.0/31. The second one is 192.168.1.1/31. And if that is the case, then the first number is basically your network number and the last number is only your broadcast address. There is no IP address to use. So what we do here is in the recent routers, not in the recent, basically it is too old now, right? We can assign, I'm forgetting that command, but I will let you know. If we can give that command, or basically in newer version of iOS, you do not need to even give that command too, right? If we are using /31, you can use this 1.0 and .1 network on these links. So basically, instead of wasting these two IP addresses, I can choose /31. If I want to give, if I know in advance, basically there are going to be only 2 hosts on this network, I can give 1.0 address here and 1.1 address here, so that I do not waste any IP addresses. Am I able to answer your question, Mr. Kamaljeet ji?
Yeah, I understand that it is used to save the IP addresses, but I'm not able to understand one point, that why there is some use for the network ID and there is some use for the broadcast IP for the
See,
/31.
Kamaljeet ji, whatever the rules we have created, right? We have created in 1980s. Right?
Okay.
And at that point of time, we were thinking 32 bits is, see, if you do not want to use it, /31, that is fine. But now in the service provider network, we do see that why do we want to waste it? So I am just explaining you the theory where we have come from /31. Now, see, we are the one who are building these routers, right? We can, just like we can explain these rules 40 years back, if there is a change in those rules, we can always update the routing, these routers, right? In the new codes, then instead of understanding these as a network number, just try to understand these as the IP address. It is as simple as that, right? So we are talking about a router which is 20-30 years old, right, or 20 years old, you cannot use this number as an IP address. The router is going to give you an error. Okay, but as soon as we come in time, we see that there are wastage of a lot of IP addresses, which we do not want to do it, and that is why we are just explaining these router through the code, right? At the end of the day, what is that? Everything is code, right? Whatever we wrote 40 years back, we can always change it, seeing the current situation, because with time, we should be moving ahead, right? We should not waste things. And we are not wasting things if we use this. I think I'm able to answer your question, right, Kamaljeet?
Yeah.
Perfect. Anybody else, guys?
Yes, I have a question. So, see, in the old days, the method which was used where, like, we had a network ID and the broadcast ID. So there was a particular use for that, like, for the broadcast IP, but when we do this approach where we have only network ID and the host IP, so what's the broadcast IP? Like, I'm not getting that.
See,
why earlier we used to have broadcast and now it's not there.
I got it. I am not saying that it is for every subnet. I am just saying it is for /31. See, I am specifically saying if I want to use /31, I need to make sure that this is the point-to-point link, and this is the point-to-point link. There are only going to be 2 IP addresses here, right? And if there are 2 IP
Yes.
addresses, then basically I do not need the broadcast. And if you talk about the point-to-point links, even we do not have Ethernet or the MAC addresses there, because we know in advance that there is only one IP address at the and I'm talking about here point-to-point link if you are on the point-to-point protocol, right? But now here I totally I am with you in this, that when we were developing, that the initial number was going to be your network number, the last number is going to be broadcast, and this broadcast number has some specific meaning, right? What is the specific meaning of this broadcast address? That inside a particular network, if I have 255 hosts of IP address, and if I send an IP address to message to 192.168.1.255, it is going to be received at every IP host. But we can say that if we want to use /31, right? Because we are wasting IP addresses. See, we are just changing the logic in case of /21. I am not changing logic anywhere else, right? But again, I am not saying that we cannot change it for other. For example, here also, I can be wasting 2 IP addresses, right? So I can say that router, you can be on the old model, that is perfectly fine. But if I say that I do not want network number, I do not want broadcast at all, right? You are taking this decision deliberately, right? Okay, I'll give you an analogy, right? Suppose in a car, nowadays there are 2 types of car. One is fully automatic, right? And the second one is basically which is your gearbox mix, right? If you have the gearbox, right? Could you please be on mute, Mr. Singh, Bharat Singh? If you are using gear, right, you are having more control because you can change the gear depending on the speed, right? Automatic is not letting you do that. You can just try to understand. Previously, we have a gear like car where previously we have automatic car, you can say, where it is defined by the system that you cannot use 1.0 and 1.3. But now you have programmed this router on deliberately. That is why you need to enable a command to do that, right? You are deliberately saying, you are deliberately instructing router that I do not want your automatic services. I want that 1.0 should be used instead of network number. It should be used an IP address. If you do not want to do that, just go to the automatic mode, right? This way, this functionality is giving you an extra edge that you should not waste the IP address. If you use this command, this router is going to understand this as an IP address instead of a network number. Okay, Mr. Singh?
Yes. So just one last question. So suppose this is the link, the router 1 and R2, which you have written and draw in front of us. So 1.1 is on the R1, and for like if on this link we want to run the OSPF or any other routing protocol, so how is it gonna work? Like, because the next hop should be reachable, then only I'm gonna send a packet to next hop router,
and
right?
who is saying this next hop is not reachable? This is reachable. If you ping from R to 1.0, it is pinging from 1. Okay, we will explain you once we will run OSPF. I will make sure that we run OSPF on this link. Okay, but we are running out of time.
Have you got my question?
I absolutely got your question. I absolutely got your question.
Yeah.
Vishnu, I think.
31.
Yeah, but just give me one minute. I think it's like a serial link. We don't perform ARP request on point-to-point serial.
No, guys. It could be Ethernet. It could be Ethernet. So believe me. Just wait a minute. Believe me. We are going to cover this. But right now, we are way overshooting the time. It is 1 hour 44 minutes, right? So probably do not worry at all. I will make sure that we will do this. We will check this everything on the point-to-point link. We can make Ethernet link also is a point-to-point link. I will let you know. Do not worry about it. This could run on the Ethernet also. Anybody else? Yeah, Burak,
Vishnu,
you have question. Yeah, go ahead.
this is my last question. In this point-to-point link, as you said, this could be Ethernet link also.
It could.
For example, yeah, we are getting an link from the service provider, and it's a Ethernet link.
What link? Actually, I think I lost your voice. Could you please repeat once again?
Ethernet link.
Ethernet link. Yeah.
Ethernet link. Yeah. In this case, when we use slash 31 IP subnet mask at both ends, in this case, how ARP is running in this link?
Do not worry. The same question is asked by Mr. Okay, let me discuss this slightly. What do you guys think that suppose I have two routers here, R1 and R2, and I am using 0.1 here and 0.2 here, not 0.1. I am using IP address 0.0 here and 0.1 here, right? And I'm using this subnet 192.168.1.0/31, right? Now the question arises that if I have a route to reach x.x.x.0/24, you need to go via 0.1. Suppose this is going to be my next stop, but the problem is I really do not want to explain all these things now because I haven't explained this. This is the time wastage for other people. But whenever we are learning all these concepts, I'll make sure that we will be using this 31 and I will make sure that we will be using ARP there. By the way, guys, in ARP, we are using F:(F:(F), which is the MAC address. We are not talking about IP address here, right? ARP does not based on this thing, right? So if you see, if you rewind the video and see, ARP is based on it. I am not saying I have to send this ARP to IP broadcast address. No, we are sending the MAC broadcast address. Just try to understand that. But if you didn't get that, believe me, I will be explaining you once we are into these concepts. Maybe whenever we are talking about static routing. Okay?
Okay, thank you.
But maybe let's till now, if it is a puzzle for you, just try to think about it and you should be getting it. Whatever the last 1 minute I have explained to you, the answer is in that, but I do not want to elaborate it because it is going to take another 10 minutes. But having said that, if we do not have any questions now, it was wonderful talking with you once again. And now we are going to see you, means I'm going to see you on Tuesday, 7 a.m. Indian Standard Time. Okay, guys, having said that, bye for now. It was a wonderful session. Thank you so much.